Assalamualaikum and good afternoon everyone. So in this video we will learn chapter 3, momentum and impulse. For learning outcome 3.1a, define momentum and impulse. So for definition, momentum can be defined as the product of mass and its velocity. Mathematically, P is the symbol for momentum equals to mass. Symbol for mass is m time velocity. All objects have mass, so if an object is moving, then it has momentum. It has mass in motion. So the unit for momentum is kilogram meter per second. Momentum is a vector quantity. So direction of momentum is the same as the direction of velocity. Since momentum is vector quantity, it has direction and can be resolved into x and y component. Look at this diagram. So this is the momentum P. Momentum P. And then it can be resolved into momentum at x component, which is Px, and momentum at y component, which is Py. And you can relate Px with P with this angle. So Px is P cos theta and Py is P sin theta, where magnitude of momentum P is equals to square root momentum at component x squared plus momentum at y component squared. And the angle theta can be determined from formula theta equals inverse tangent momentum at y component over momentum at x component. Now we can proceed to impulse. Impulse is the product of the average force F. Average force F and the time interval during the force act. So in mathematics, impulse J, symbol for impulse is J, equals to force times time interval dt. So impulse is also vector quantity and the unit is Newton second or kilogram meter per second. It is the same as the same unit as momentum, because impulse is the change of momentum. It is like this. Impulse is also equals to change of momentum, where it is equals to momentum final minus momentum initial. So momentum final is mass times final velocity v, and momentum initial is mass times initial velocity u. So unit for impulse is the same as unit of momentum. It also can be resolved into x component and y component. So this is the impulse tilted. So you can resolve into x component and y component. Alright, so the magnitude of impulse J can be determined by square root of jx squared plus jy squared, and this angle will be given, or you can determine from the formula theta equals to inverse tangent jy over jx. J is the symbol of impulse. Okay. Okay, when two objects is in collision, the impulsive force F against time t graph is given by the area under the graph. So impulse, where the symbol is J, is also equals to area under the graph of force against time. Okay, so for example, we have this force shape of graph. Okay, this one is rectangle. Okay, so this is graph of force against time. So area under the graph represent the impulse. Okay, so area under this graph is, okay, because this is the shape of rectangle, so this is length times width. Okay, and then for this one, graph of force against time again, and area under the graph represent impulse, the shape of triangle. Okay, so half times base times height. And then this is the shape of trapezium. Again, this is graph of force against time. So area under this graph equals to impulse. And then for this one, curve graph, okay, graph of force against time. So area under this curve equals to impulse. Okay. Okay, now we go to impulse momentum theorem. Okay, when a net average force F acts on an object during a time interval delta t, the impulse of this force is equal to the change in momentum of the object. Okay, impulse equals to the change of momentum of the object. Okay, this I like I mentioned earlier. Okay, impulse equals to change of momentum. So momentum final equals to mass times final velocity v, and momentum initial is equals to mass times initial velocity u. Alright. Okay, then we can proceed to conservation of linear momentum 3.2. The learning outcome is state the principle of conservation of linear momentum. Okay, principle of conservation of linear momentum state that the total momentum of an isolated system is constant. That means total momentum initial is equals to total momentum final if there is no external force, or the net external force is 0. Okay. An isolated system is a system for which the net external force is 0. Okay, so an isolated system is one on which there are no external force, for which the external force are balanced and add to 0. Okay, so from the Newton's second law, where net force equals to 0, so net force equals to total, net force equals to rate of change of momentum. Okay, rate of change of momentum equals to 0. Okay, so change of momentum equals to 0. So dp equals to 0. So momentum total momentum initial equals to total momentum final. Okay. For example, we have head-on collision of two balls labeled A and B. Okay, where ball A with mass ma and initial velocity ua move to the right, and ball B with mass mb and initial velocity ub move to the left. And then they collide, and after that, ball A, okay, move to the left and ball B move to the right. So ball A move to the left with final velocity v, okay, and VA, and ball B move with final velocity VB. Okay. So we can have this equation. Okay, total momentum initial equals to total momentum final. So momentum initial come from momentum of ball A and ball B. Okay, momentum of ball A is ma ua and momentum of ball B is mb times ub. Right? And then total momentum final come from momentum of ball A and momentum of ball B. So it is equals to ma times final velocity ball A VA plus mass of ball B times final velocity ball B. And then you can substitute value of mass and initial velocity and final velocity for each ball. Okay, but remember the U and V are vector quantity, so you have to consider about the direction. Okay, UB is to the left. Okay, UB is the left, so you must write negative sign for UB when you substitute the value of UB. Alright. Okay, so we assume the net external force on this system of two balls is 0. The only significant forces during the collision are the forces that each ball exerts on one another. So this is the graph of force against time. Okay, force against time. So we have this kind of graph. Okay, before collision, that force is 0. And then during collision, force is increased and then decrease, and after the collision, the force is 0. Okay, so the net force is 0. Alright, the momentum of each of the two balls changes as a result of the collision. The sum of their momentum is found to be the same before and after collision. Okay, this is the same like I write the formula before. Okay, which is ma ua plus mb ub equals ma VA plus MB VB. Okay, MA is mass for ball A or object A. Okay, collision is between two objects. Alright, and MB is mass for object B or ball B. UA is the initial velocity of ball A, and UB is initial velocity of ball B. VA is final velocity of ball A, and VB is final velocity of ball B. Okay. Although momentum is conserved in all interaction, not all interaction, collision, or explosion are the same. Okay, the possibilities include a single object can explode into multiple object explosion. Okay. Okay. So for this one, can be MA plus MB because initially object 1 and 2 stick together, so they share same initial velocity. So after the collision, they explode, they move separately. So it will be MA VA plus MB VB. Okay. Alright. And then for condition 2, multiple objects can collide and stick together, forming a single object with common velocity. Okay, so this is called completely inelastic collision or perfectly inelastic collision. Okay, so this one, the formula will be like this: MA UA plus MB UB equals to MA plus MB times V, because after the collision, object 1 and object 2, or object A and object B, stick together, so they share the same final velocity V. Okay. And then multiple objects can collide and bounce off each other, remaining as multiple objects. Okay, so this is the same. MA UA plus MB UB equals MA VA plus MB VB. Okay. And then for this kind of collision, okay, they bounce. Okay, they bounce. So maybe this lorry, okay, this lorry move to the left. So let's say this is object 1, this is object 2, or this is object A, this is object B. So for final velocity, VA here, okay, VA here, you have to put negative sign because it moved to the left. Okay, you have to consider the direction, okay, the negative or positive sign. Okay. Okay, so all these formula are general for one dimension. Okay, but if this object tilted, okay, you have to resolve into x component and y component. So you have to divide the momentum into x component and y component. Okay. So like this, for x component, momentum initial x component equals to momentum final x component. Okay, so it is like this, M1, MA, okay, MA UA for x component plus MB UB x component equals to MA VA x component plus MB VB x component. Okay, so this one is for x component. Okay, and then for y component, this one, momentum initial y component equals to total momentum initial y component equals to total momentum final y component. So it will be MA UAY component plus MB UBY component equals to MA VAY component plus MB VBY component. Alright.